Okay, so quick poll before we start. The topic of this panel is: do you need a container storage system? So who thinks we need a container storage system? Who thinks we don't need a container storage system? One person. Okay. Well, I'm just like, why are you here at a storage day if not? Anyway, so I kind of assume that most people agree with this statement already. Anyway, I'm Cheryl. I am the Director of Ecosystem at the CNCF. Full disclosure, before this, I was working at StorageOS as a product and DevOps manager. So I'm fairly into my storage. And before that, I was an engineer at Google. Would you like to introduce yourselves?
Hi, my name is Gou Rao. I'm the CTO with Portworx.
Hi, I'm Steve Watts. I work at Red Hat. I lead the Emerging Technologies Group and part of the crew that founded the Kubernetes storage SIG back in 2015.
So hi, my name is Jeffrey. I am the CTO at MayaData, who sponsors the OpenEBS project, which is building a platform for stateful workloads for cloud-native applications.
Cool. So I've got a handful of questions, but I will ask for audience questions a couple of times as well. So keep thinking. So let's start off with how has Kubernetes evolved as a platform for storage? Perhaps since you have been there for a while, maybe you can give us an overview.
So I was remarking to Alex earlier about some of the things we're not having to still deal with, which was when around 2015 we used to get a lot of clickbait around the fact that solving the container persistence problem, which Kubernetes had addressed, but that was in part through the Kubernetes storage SIG starting in 2015, coming up with persistent volume framework, the adapters, the volume plugins, and that basically lay the building blocks for us to be able to do network attached storage, whether it's file or block, into our containers. But I think something that's kind of fun or funny artifact of that is, like, if you look at the cloud native patterns, what is one of the main ones is self-service, right? And so we were like, yeah, the fact that the developer has to call a storage administrator and say, I need a volume, and get that volume back 3 days later, that's broken. That's not the cloud native way at all. So we said, oh, okay, we're gonna claim volumes and dynamically provision them, which was awesome and great. And then I noticed, like, about 18 months later, where we're getting all these inquiries around, like, what's the difference between read write once and read write many, and like block and file, like stuff developers never had to understand, because the storage administrator that they would call up would always like say, what are you trying to do, and figure out the right volume for them. So I think that's kind of an interesting artifact of like how we've developed, but I'm pretty stoked at, like, 3-4 years down the line, that we actually have a pretty robust working thing with a good ecosystem around it.
Cool. Do either of you want to add anything?
No, I mean, exactly, to just add on to what Steve said, if you, look at the evolution of Kubernetes itself, right, and a couple of years back, a lot of the constructs around it were really focused on just stateless, right, part of just getting the compute running, service discovery. You look at the, what's happened over the past year or two, a lot of the I'm going to call the grammar around Kubernetes has been around how you manage and facilitate state. Be it something like being able to take snapshots, being able to do multi-cloud workflows. So a lot of that is just the evolution around the verbs, the nouns that are used around Kubernetes. There's a lot of thought that this ecosystem, the SIG that Steve talked about, has been working on, around just managing and facilitating the state of an application, even beyond the application's lifecycle, right? So when a container goes away, there's still state associated with it, like the PVCs. Can they be used by another container at some other point in time? How do you do it? What's the namespace scoping around it? The access controls around it. So a lot of that has been work that we've been working on, and I think that that's going to continue to happen.
Yeah, and I think that if you go all the way back to the Borg paper, let's say, I think the word storage is mentioned 4 or 5 times, excluding references, by the way. And so if you ask what has happened since then, I think a lot has happened since then. PVs, PVCs, the CSI spec, and all the ongoing efforts like snapshots, like you guys mentioned. But that all still talks a lot about interfaces, right? There is a storage system, and this is how you interface to that storage system. It doesn't necessarily talk about, okay, how do I do this from a data plane management? So I think that there is room there to innovate. And I think one of the most important things, and that we talk about this, and I think that the sheer size of the event demonstrates that's needed. But I think it is important that we learn from these cloud native engineers, let's say, to make sure that we engineer from top down instead of bottom up, which storage vendors typically like to do, myself included. This is my device and it's precious, and I need to make sure that people can use it effectively in the way I want it. But providing cloud native storage from a data plane aspect, I think that there is a lot of room for us to learn and provide a good solution for that.
So I talk to a lot of companies, end users, companies that want to adopt Kubernetes or cloud native, but they're not selling services themselves. And one of the things that I hear a lot is we're interested in multi-cluster or even multi-cloud storage. So what are the challenges that you're seeing there?
Yeah, it's interesting because a lot of times people will ask, well, actually, I get asked this a lot, which is, what is actually driving multi-cloud and multi-cluster workflows? And here, the bottom line is, look, if somebody has thousands of nodes and they're running Kubernetes, it's typically not one very large Kubernetes cluster. People are running multiple clusters, whether they're trying to facilitate blue-green deployments, whether they're trying to create a dev staging production cluster, they're running different versions of software. We just heard from Paul Davis from Comcast earlier, multiple clusters, testing out newer versions of software. So what this does is, if everything is stateless, then you probably don't have too much of to worry about. But when you have state associated with it, does this, if I have even, say, for example, 2 clusters, does my second cluster have access to the same data? How am I going to do copy data management associated with it? So a lot of thought needs to be put into the storage layer when it comes to managing state across multiple clusters. So at Portworx, for example, we have certain features built in where we can allow the access of data across clusters. I know Red Hat's working on exactly similar solutions there.
Yeah. You want to add something?
Well, yeah. So the whole multi-cluster thing, multi-cloud thing, when either it's public or private, I think one of the biggest problems to solve is that how do I achieve data mobility between these different sites, whatever the storage system is, right? So you effectively need to find a way where you can make the volume omnipresent, despite of the underlying storage system, right? And so what I mean with that, from a very practical example, if I have my private cloud and I use Outpost or GKE on-prem or whatever in my data center, and I want to transparently move or scale that up into the public cloud because of resource constraints, how do I make sure that the data is there when it actually needs to be there? And doing that requires some thinking, and more so because you really want to make sure that the developer is in control and not that there is the storage admin all the way down in the basement that says, no, it's not going to work today because I'm running backups or whatever, right? So the developer needs to be in control, and you need to have transparent portability between these different type of clouds. And it shouldn't be a matter of the legacy vendors cannot do this or whatever. I think that there is room for us to provide value on top of these legacy vendors and not necessarily fight against them.
Yeah, I agree on that. I think there's some value in the abstraction.
Yeah.
I'll touch on that too. I think it's a good point. So I look at it like they're chapters in the history of enterprise architecture. And so like if you had chapter 1, which was like scale up, where a lot of applications were built on a single server. And then we, as an industry, realized like there's limitations to scale up. So we came up with scale out architectures and clusters. And so that was sort of like the second chapter in the evolution of enterprise architecture. And now there's this, that's great, but actually, as we build applications, we have clusters tend to have different properties. So you might have a cluster that's location specific because your application might need to be closer to its user constituents, or another cluster is low power, or you're in the telco or oil and gas industry, and it needs to be on the edge, hyperconverged or something. So we're now in this third chapter, or driving towards it, where we now need to be able to develop applications, and then in our build pipelines, choose which clusters they go to. So that's the first aspect of it. And then the second aspect is the data services that are required, because ideally also nobody particularly wants to get trapped in one particular place when they deploy something. We want to make it as easy as we do. Kubernetes is just wonderful at making deployments simple, right? Think about like when we were doing scale out deployments. I come from the Hadoop community. There's an old buddy of mine, Jeremy, from the Hadoop community here too. Like when Hadoop first used to develop and we go to the enterprise community, it used to take them like months to like figure out how to deploy a Hadoop cluster, or at least train their teams. Like I went and like deployed like the Weave SDN with like one command, like boom, across my whole cluster. It's changed completely. So to be able to sort of bring that simplicity for portability between clusters and be able to have that storage abstraction across, so that we can not only deploy to different clusters, but move applications between the clusters, I think that's really exciting.
I just want to add to what Steve said. I don't know if this was evident enough in Steve's description of multi-cluster challenges. One thing that I think Steve sort of alluded to there was that your physical environment for the clusters are going to be different. So what you're programming to your platform for is a common, think of it as you want to program to a common denominator, and that common denominator platform can run in different physical environments. Specifically, what I'm getting at is if you're running multiple Kubernetes clusters, your storage systems in the back may not be the same, right? So right. In one case, you may be running in Amazon, and the storage backend may be coming off of EBS volumes. You may have a similar cluster that's running on-prem, but these are servers with direct attached drives. So how do you manage or facilitate the state sharing across these different clusters when the physical environments are so different? I think that's where a lot of the challenges are, and that's what I think this ecosystem will be focusing on over the next couple of years. The other thing is, your actual storage implementation may be coming from different vendors, and so when you talk about multi-cluster workflows, can those two different storage architectures share data between each other, not just at the physical layer, but even at the software layer? Right.
Cool. I'm going to take a pause there and ask if there's any questions from the audience. At the back, do we have another? One to the back. Who is it?
I know. Okay, there was a hand up. I wasn't sure if you had.
Hi, thank you all. I was wondering how often you find a true stateless application or whatever as compared to stateful.
Well, so I think that personally, I feel that there is no such thing as stateless, right? I mean, inside of the computer, in the main memory, in the operating system's handling of your program, there is a state. I think the thing is that does it matter if you lose the state, and what is the impact if you do, right? So to put it in perspective, the worst thing that can happen to me, I suppose, is that when I have filled my basket on Amazon, let's say, and I want to check out, I have to restart from scratch because something crashed, right? So the impact is not all that big. In terms of storage, cloud native storage, you typically lose a lot more than that, right? I mean, usually the data is like the crown jewels of a company, and it contains everything, their value, their customers, and whatever. So the impact is a lot bigger. But back to your original question, how often do you see completely stateless things? Not all that often, but it depends a lot on the impact that it has.
Hi. I was wondering what you could say about the relationship between Docker volume driver plugins to Flex volume to CSI, and what sort of limitations caused the evolution there, and what do you think would be the next thing that causes us to abandon CSI or evolve CSI?
Well, okay, so
I think this question should also tail into lunch, so stick around, and there's a very much longer answer to that, but let me give you guys some.
So just some history there. So when we first started building the volume plugins, they were all entry, and we were still trying to figure out exactly how the persistent volume framework worked, right, and how it needed to work. And we also didn't have a whole lot of community participation. Like, you know, candidly, it was like 7 people in the SIG that were writing the entire ecosystem's adapters. Like, so you know, like Red Hat and Google were writing like the EBS adapter and stuff. You know, like so we got to this point where eventually, like, we kind of figured out, okay, this persistent volume framework works the right way. We've got the right volume plugins that they interact properly with the PV framework. Great. Kubernetes really started to take off at that point, and the storage ecosystem started to show up. Like, I think we went from like 7 people in the SIG to 50 people in the SIG in about 8 months. And then as the vendors showed up and said, hey, we want to maintain and write our own plugins, how the heck do we do this, right? And so like Flex Volume evolved out of that. The guy 2 people behind you is actually the guy who wrote the first one, Chakri. He's looking at his phone right now. So that was great, but like Flex Volume had some limitations, but it was the first out of tree framework that could be used to build volume plugins. And then at the same time, some folks started this idea about like, well, what if we had some sort of industry spec for creating an external adaptive framework that would work across industries? And that occurred at the same time that the Kubernetes community were wrestling with what spec do we create, a Flex Volume version 2, or do we join this container storage interface and use that as our out of tree spec that we tell the industry to build adapters to? Because despite the K8s community being quite open to folks writing more entry drivers, we were still getting feedback like, it's too hard, we can't figure out how to join the community. There were like a lot of, like, say, proprietary software vendors that were new to open source, that like the governance and like how you get stuff in, it was just kind of opaque to them. So ultimately, that's what we decided. I don't think, you know, there's much likelihood we abandon CSI. I think like was just a natural evolution of moving from entry to out of tree, and then the trade-off between version 2 versus CSI, and we decided to go with CSI, so the end of story.
There was actually, I think, another part of your question, which is you asked about DBDI, or the Docker volume interface, and what, yes. Right? And I think one of the big advantages that in how it's done with CSI and Kubernetes is that the orchestration of your volume lifecycle, like the attachment and where it gets attached and when does it get detached, that's maintained by the orchestrator, by Kubernetes, as opposed to being done via the container runtime engine. So with going through DBDI, you're deferring that to Docker, and so you end up having additional dependencies. Done this way, it's not tied to the container runtime necessarily, and the orchestrator is able to directly manage the lifecycle of the volume. The other thing in CSI that makes it advantageous, you said, what's the risk of it getting obsolete, is that I think it's extensible, right? So whatever we're going to do, there may be things in the future that we're going to come up with that we haven't even thought about, right? So for example, could be more complex lifecycle management associated with the state of a volume post the container's runtime. That's possible to do with this extensible, you know, in how CSI is currently defined. It leaves it open to future enhancements that we don't have to abandon it and do something else, if that makes sense.
Yeah, and just to add to that a little bit is that, you know, what type of extensions would that be, right? And one of the, you know, I guess one of the emerging technologies is NVMe over Fabric, and then we talk about RDMA and these type of things, persistent DIMMs. So, you know, if you want to do high performance workloads, you need to find a way to abstract these systems as well and make sure that they work nicely with the CSI specification. So I think it will be an evolving spec for a long, long time, and I think it's probably the best way forward and your best bet to contribute in a meaningful manner to Kubernetes and the whole ecosystem around it when it comes to storage.
I just want to add, like, there's one pattern I've been observing in the K8s community, which is like when the K8s community feels like they need something added to the storage framework, you know, I don't know, cloning or, you know, host assisted cloning or something. Like the pattern seems to be like use CRDs and try it out and then discuss it. And then once you've got like a working implementation, take that to the CSI, which is a completely separate community, by the way, and sort of demonstrate like, hey, this is the flow around this. What do you think? Here's some data points around it.
And that part is important because when it comes to storage and Kubernetes, I think what we're doing right now is I look at it as the first chapter. It's been around basically orchestrating how volumes get provisioned and consumed, the whole programmatic aspect of things, where you don't have a storage admin that has to go in and provision the volume. So that's sort of where we are today. But where is this ecosystem headed? And I think it really is around having intelligent operators that can do more application-specific monitoring and probably reacting to how the application is consuming storage. You have complex applications like, for example, Elasticsearch, deciding when do I shard my data? Am I operating at in an optimal manner? And so all of this intelligence doesn't exist right now, but it's feasible to build these type of, extensions for your stateful application.
Yeah, and I think that there's, to add to that, it's a very good point actually, because I was just talking about it, some of my colleagues about that, is that with these new emerging technologies where you can have a single NVMe device, let's say, that does over 1 million IOPS, it's not apparent what you need next to that actual device, but you need a certain amount of CPU and whatnot. And there right now is not a real good abstraction yet how I actually can observe the storage state from a generic standpoint. So, how are these systems tied together? And things like NUMA awareness also come into account when you deal with these high performance workloads. And I'm not saying that we need those now, but in 3 or 4 years from now, let's say, you will not be able to buy a non-all flash system, whatever it is, commodity or an enterprise system, right? Because these systems will just go out of use, let's say, and you will have these 2 tiers, flash and trash, where flash is for the high-speed workloads and trash is for your objects and deep, big, fat storage buckets, let's say. So I think that there's still a lot of room to get some observability and generic abstraction around storage resources in Kubernetes in general.
Let me turn the question around another way. So somebody said before, like in the old days, like 3 years ago. So let's pretend we're doing this panel in 2021. And what would you say? God, in 2018, we were so worried about how to do X, and now it's just a solved problem. What would you say?
Yeah, I think that's a great question. I think if we fast forward a couple of years from now, what would we be talking about? And I think it's going to be around this ecosystem would have evolved in such a way where I think there's a lot more AI and analytics built into the storage system to be able to react to different types of applications. I think you asked a question earlier, which is, is there such a thing as truly stateless? I mean, it's possible to design a system that's truly stateless. I think what we're finding, especially, at least in my opinion, what we're finding is that most enterprises want to be able to manage state with the application more tightly. And so if you have a strictly state is outside of my Kubernetes environment, it becomes a little bit more difficult to do that. Where I'm going with this is once you buy into the, or subscribe to the notion that state will be part of my application, you start, being more intelligent about how you're managing that state within your container orchestrator environment, which means that the storage ecosystem associated with managing or just provisioning volumes, that's not enough. You need something that is more aware of what the application is doing, being able to react to it, or maybe even monitoring the underlying infrastructure, and then therefore giving hints back up to the application and how it needs to change its configuration. I think that's what we'll probably be talking about in a couple of years. How are we getting that intelligence from the application to the orchestrator and vice versa, from the orchestrator down to the application? And I think that intelligence layer is going to start being built into the storage system. And then where I think CSI will probably evolve potentially is being able to facilitate that intelligence back and forth.
Steve, Jeffrey, these solve problems.
Yeah, so we're 2021 in the future. Well, yeah, it's always hard to predict, of course, but I think that one of the things that we will see in general in these environments is that it will not just be containers anymore. I think that the recent announcements, like around Firecracker, let's say, where they strip down the hypervisor to a bare minimum just to run containers in a secure fashion, we'll see a lot more of that, and kata containers and things alike. But also more the traditional type like VMs, like let's say the fat VMs, for lack of a better word, like KubeVirt, right? So Kubernetes will be the universal control plane to manage all these things, and that would be a transition phase for eventually having everything run in your application, because companies will not throw away all the multi-million dollars or whatever the amount is into their infrastructure, whether it's virtual or physical, right? So you have to find a way that you can repurpose it for at least 3 years or so. With that, the requirements in terms of how you configure your storage becomes even a bigger problem. And also, I think by that time, I think segregation of storage will happen again. Hyperconverge, sounds good, but that was mostly around based around the fact that the CPUs in these storage systems were twisting their thumbs because the devices, 2 millisecond latencies. That's going to change as well. So I think that segregation will take place again during that time frame, and we'll see obviously how that goes. But yeah, I think more different type of workloads in different execution environments will be there. I think. Maybe we should put it in a jar and dig it in a hole and dig it up later.
So I would just add that just very specifically, I think that we're going to see a whole lot more API and volume vendors per the taxonomy Alex showed. That like as an example, like Cassandra as a API data management system, and anything that backs a PV today. The volume, those distributed systems running in Kubernetes. I think one thing I'd like to add earlier was that that support for local disks, right? The intent, at least from our engineers, the Red Hat engineers working on that, was to make it so that when you're deploying these distributed data management platforms on premise, like the way Mongo works, or Cassandra, or HDFS, or Gluster, or Ceph, whatever, they have many different nodes. Each one uses a local disk, right? To be able to deploy that as a stateful set or an operator, and just have it to be one command, and just rather than this very tedious way that we have to do that today. And so I think you're going to see more of that for the industry coming together, and then specifically on this multi-cluster, multi-cloud, I think there's the potential for some multi-cluster operators. So a single operator that can deploy a storage platform across multiple clusters wherever they may be, public or on-premise, and that provide the data services or fabric between them. And I think I agree with what Gou was saying on the intelligence side, but I think there's also like the admin side of that, where the admins are going to want to basically lay down a storage fabric across the clusters, have it be intelligent as well. So it's more on the compute plane, have the intelligence to maybe know which clusters to go to for certain things, but also just to make it really easy at kind of what operators do, right? Just make deployment across multiple clusters really easy. That would be my guess.
Yeah, or maybe that the AI comes with an advisory, right? I mean, just like an intermediate step, hey, this workload is getting more latency and this box is doing nothing. Should I move it? And you just click yes or no, right? And pretend to be very busy at work analyzing that data. But, some form of controlled AI, let's say.
Policy.
Policy.
We need policy, like in our control plane.
Okay, awesome. We are out of time, unfortunately, but I hope that you will stick around for lunch and be able to answer more questions from the audience if people are around.
Absolutely.
Great. Okay, thank you. Round of applause.
Thank you.